Hi, in this video I have a kettle. This kettle is not switching on and I'm going to demonstrate how to fault trace a faulty kettle. Right, your plug top will probably be different. I'm going to demonstrate, I put it on there and you can see it is not going on. Normally there would be a blue light here showing you that the power is on. Alright, so first thing I'm going to do is unplug it. And now the first step is to inspect the base. Check the condition of the cord. This here is just glue. Someone's glued it so that it can seat in that position over there. Right, I unwind this and there's nothing really visually wrong here. Right, now I have a multimeter here and what it's measuring is continuity. So when I touch the two leads together, it should make a noise. Right, so if you look inside here, you see two metallic platforms. And if you look at the bottom of the kettle, you'll see these rings. Now, what will happen is when you place this on here, the ring seats on the platform making contact. So one of these is the live and one is the neutral. One of these rings will be the live. And when you put it on there, it will make contact. Doesn't matter if this moves because as you can see, it is round. So what I want to do is I want to check that from there to there is conductivity. So I'm going to touch my electrode on the one pin. Now, if your plug looks like this, it's fine. You'll do the same, but you'll just put on the one prong there and you'll put the electrode over there and your other lead over there. Right, now in my case, this plug top looks like this. So I'm going to press there and I'm going to find the metallic contact there. There we go. Right, so you can hear that. That's telling me there's a short circuit. Now I'm going to test the other one, just making sure there's no short. Right, nothing there, but it should make contact here. Okay, so far there's nothing wrong here. Now what you could do is put this like this and then fiddle with the wire, just checking if there's anything loose. And in this case, the base is fine. So I've now worked out from here to here, there's no fault. Right, now the next step is to open this. So on the back here, I see 3 star screws, and then there's one hidden inside here. Right, now there is one hidden over here, so I'll just release this gently. Right, the glass can come out, but I just want to open here. Right, so the back part here can peel up. So I'm just going to insert my screwdriver there. Just tap it in. There you can see it's inside there now. And as you can see, I just lifted that. Right, there's that third screw. Right. Right, so I'm going to take this handle off. What I'm going to do is, you see I've lifted the lid. Now all kettles are different, so I'm just going to slide that up. And as you can see, I can now release this completely and now I can test the individual components. Right, so the first thing I want to test is the heater. Here's the element and that's what gets hot. That's what uses the bulk of the electricity. So I'm going to put my one electrode there and my other one there, and there you can hear. Now I want to actually measure the resistance. So from there to there, you can see that it's 26.5 ohms. There's nothing wrong with this element, so the element is therefore working. So now I'm going to see where else there could be a problem. Right, now as you can see, from the one side of the electrode, it goes to the ring. See, that would be the neutral. So there's no problem from there to there. There's no problem from there to there. Listen to the sound. Right, so there's the neutral connected to the outer ring and the inner ring is connected to the live. So here is the live terminal and you can see that the live is fed right down here and it goes to the switch. Now in this case, the switch is in the handle over here. Right, so what I'm doing is I've just taken this out. This is just the rocker and there's the switch inside there. So I'm going to remove it just to fault trace it. Here's the switch, and this switch is controlled by this disc, and as the heat gets close to this disc, it actually heats it up and the disc changes shape. When the disc changes shape, you can see it does this, therefore opening and closing this switch. This becomes a switch. So what I want to measure here is I want to see that this is still working. Right, so I put my one lead there and my other lead there, and I measure the function of the switch. Yes, open, closed, open, closed. Open, closed, open, closed. Right, so this is actually working. But what I am noticing is some ants are actually falling out. I don't know if you notice all these black things here on the table. These are ants. And I wonder if some ants were getting in the way here. All right, so there's actually nothing wrong here. And what I like to do is spray a contact cleaner. This just cleans away some of the oxides. If you haven't got this, it's fine. I'm just going to spray it here on the surfaces. And that just removes the oxides because of all the moisture Right, so this switch is actually working. Right, we've got these two LEDs here. All they do is they seat in this ring, and this ring illuminates, showing you the kettle is on. Right, the last thing that is here are just these wires here, and this is probably a resistor encased in this heat shrink. Right, so these are LEDs, and this is just a volt drop to reduce the voltage for these LEDs, so it's probably a resistor. And then it's got these thermal protection here. It's got the heat shrink. Right, now for the final check, we want to go from the neutral ring to the element. No problem. Right, now from the output of the switch to the inner ring, I'm getting nothing. So there's the fault. Nothing from there. So is this wire faulty, or is there something faulty here? So what I'm going to do now is I'm going to pull out that electrode. Right, so I'm opening this over here. I'm just taking pliers and I'm removing that. And now what I'm going to do is I'm going to measure along this wire. So I'm going from there to here. And as I suspected, there's nothing wrong with the wire. So there's a fault from there to there. If you have a look, from that lead to the inner ring should be 0 ohms. And it's not. So now I'm going to open this up. Right, so there's the fault. I've got my one lead on the live terminal there, and then on the inner ring, you can see it is conducting now. But then, can you see that when I pump this? See, it's almost like it's loose. You can see there. And then when I lean it here, you see gravity is helping it, but that is too sensitive. Right, so there you can see I'm checking the neutral, and you can see that the neutral is working fine. But when I go to the live, you can see that the live's the inner ring. Look at that, 1 meg, kilo ohm. Then it's fine. Then it's open circuit. You can see there, so it's almost like it's loose. So I'll just open this up and show you what's inside. Now I've taken those 2 screws out, and then there's a piece of metal that has to just be bent over here. 1, 2, and over here. Right, so I've just made those straight so they can slide out. Now just be very careful when you open this. Now, if you're wondering why it's wet, it's just because I sprayed some contact cleaner in there. Right, so I'm briefly going to explain the principle of operation of this. Now, the live comes in over there. How do I know that? Because you can see that's the inner ring, and it is fused to that point over there. The live current flows from here to here, and there's actually a contactor there. If you can have a look there, you can see I can open and close that. Then the current flows to here, and then it went to the switch. Now, as the kettle is switched on, it gets hot, and what happens is it uses this to cut out the current. This is called a thermal cutout, and this is using a bimetal disc. I don't know if this particular one is the bimetal disc, but what happens is as this disc heats up, this disc is sitting on the element. I'll just show you over here. So this disc is sitting like that, so that is touching there. Right, so this white stuff is silicone grease. There it is. Those familiar with CPUs, MOSFETs, and electronics will know that you put the silicone grease to improve the conductivity, because this sits on that and it conducts the heat from here to here. And this metal disc, as it gets hot, it changes its shape. And that shape change is what's important here. So when this cover is on, what happens is this disc changes shape, and when it changes shape, it goes like that. And when it changes shape, it pushes on this pin over here. And when this pin is depressed, it separates the contacts. Now this pin is not plastic, because remember, this gets pretty hot. Therefore, this pin is fiberglass or a ceramic material that can handle high heat. And what happens is it presses and opens this contact, and when it opens the contact, it cuts out the supply, and therefore your kettle switches off. Now it has it on both sides, so this is quite safe. Just in case the one doesn't open, the other will open, and therefore it has got double protection, because there's the live and there's the neutral. Right, now sometimes on old kettles, the contacts over here get carbon buildup, and I'll just open this to show you what happens there if I take it out. I've already cleaned mine because I sprayed it with a contact cleaner, but if you have a look there, there is some arcing that took place there, which is quite normal. And all I do is I take some fine sandpaper and just clean the surface. That's all. And if you want, you can spray a contact cleaner. This is not oil, it is a contact cleaner, and it removes the oxide and helps remove the carbon buildup. So you can spray this on the surfaces if you wish. If you haven't got that spray, it's fine. You can leave that step out. It's also a good idea to inspect the curvature here of this leaf spring. If this is not curved enough, you'll find that it doesn't make good contact. Right, so there you can see it is spring loaded onto that contact. Now I can put that pin back. Right, so there's that pin. And now I can close this up. This is directional, so you must just check the way you put this back. Right, so there you can see a side view, and as this disc changes shape, you can see it opens that contact underneath there. And the same on this side. As that disc changes shape, it opens that contact underneath there. Now it's time to close this up and return this. Putting some more silicone paste here, and that's there for a reason. What I'm doing is I'm putting the thermal paste back on here, and now I'm going to rest this, and this must be fastened very firmly on the plate over there. Right, so you like to do a quick test there. There's the live, and I'm just going to do a continuity test so you can hear the beep. The live to the inner ring, and then the neutral to the outer ring. Right, now I can put these terminals back. Right, and how the kettle works is because this has a ohmage, it doesn't allow the current to flow that easily, and because it's got that resistance, it heats up. And as it heats up, it therefore boils the water. Right, now it's important to seat these electronics in a way that do not rest on the hot part of the kettle. You can see it's got these protective covers there. That must be there just in case it touches the aluminium plate here and it doesn't burn. Right, so here's the kettle. It's on its platform. I switch it on. You can see the illumination has come on. And there you can see it turns itself off. So it cuts out on the switch, and then it's got that protection. Just in case the switch doesn't work, it has a thermal cutout which will disconnect the element. Right, so that's how to fault trace a kettle. Thanks for watching, and cheers.